Hi, Mr. Moss here, and in this video we're going to be working on solving fraction word problems. We're going to be using model drawing as a strategy for this. This is the first in a series of videos covering this topic. This will be part one. And one of the things we talk a lot about in class is that we use bar models to solve word problems because they have the versatility to grow with us and to fit a bunch of different situations. We might not feel like we need them early on to solve them, but as problems get more complicated, and you'll see that example in this video, you'll see that they have more and more of a value. So let's look at the first problem here. I know it's a little small here. Tamika ran 2 5/8 miles. Her sister ran twice as far. How far did Tamika's sister run? So I'm going to set up this bar model the way I set up a lot of bar models. And again, as I do this, you'll know that bar model and tape diagram, we often use those two terms pretty interchangeably. We've got Tamika and we've got her sister. We don't know her name, so let's just represent her with an S. So we know that Tamika ran 2 5/8 miles. So I'm just going to draw a bar here to represent the 2 miles that she ran. And the 5/8, I'm going to draw the 5 parts here. 3, 4, 5. And in order to make clear that this is 5/8, because really you don't know, is that 5/5, 5/6, 5/10? We're not sure yet. So I'm going to represent that portion as being 5/8. So I've shown Tamika's amount. Now we know that her sister ran twice as far. So I'm going to recreate what I already had here. 2 and 1, 2, 3, 4, 5. And we know that you ran twice as far, so let's do another 2 miles. And another 1, 2, 3, 4, 5. Now the question is, how far did Tamika's sister run? So I always like, when I'm drawing a bar model, to find a way to make a note of what I'm trying to figure out. So it's really this section right here, what her sister ran. That's what I'm trying to figure out. How far is that? I could sit here and I could try and count it up, but we can reorder the parts of this bar diagram to be a little bit more clear for us. So I'm going to come up. Let me just switch to a new fresh color here. I'm going to make a new row for her sister. It's still the same sister, but this time I'm going to represent the whole number of miles together. So all I'm doing here is I'm taking the 2 miles here, bringing that down, the 2 miles here, bringing that down, and now I've got the 5/8 and the 5/8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now a lot of students might come here and say, okay, I'm going to draw 2, and then maybe they'll draw a box here and call this 5/8, and they'll mark it as such within one single box. Here's why I like to keep each of those parts, in this case, each of those eighths, as separate boxes, because now I can look and say, okay, I know I'm working in eighths, right? I know I'm working in eighths, so I'm going to indicate what the whole is. 8/8 is going to make a whole, so I know 1, 2, 3, 4, 5, 6, 7, 8. 8/8, that's another whole right over there. So I can quickly add these up and conclude that I've got 2 plus 2 plus 1 equals 5. So I've got 5, I'm sorry, yes, 5. And then I've got here, my remaining portion is 2/8. So my total, how far Tamika's sister ran, 5 and 2/8 miles. Now, there are plenty of other ways that you can do this, other ways to draw it out, other ways to represent this amount. And you may find that for this particular problem, you don't even need to draw it out. Again, we're looking at how to represent this visually, because as the problems get more and more sophisticated, it will be more and more helpful to be able to represent this. So let's continue. So the next example here, looks at Natasha's sculpture. It is 5 3/16 inches tall. Maya's was 4 times as tall. So far, we've got a really similar problem to the last one. The last one was twice. We were multiplying by 2. And we should, by the way, I'm going to go back to this one for a second. I always like to pull out the equation that we can represent. So we know that it's 2 5/8 miles that Tamika ran times 2, because it's twice as far, equals, we concluded, 5 2/8. So if we look at this one, now our equation, we're looking at 5 3/16 times 4. That's at least initially, but then you get to this last part right here. How much shorter was Natasha's sculpture than Maya's? Whenever I'm seeing a comparison and we're talking about shorter, bigger, longer, faster, slower, and we're comparing it to something else than someone else's, that makes me think that we're going to be using some subtraction. So I know that this equation, this is going to probably help me out to get started, but it's not going to give me the answer fully. So let's start off with our model drawing. I'm going to again set up for our bar model. And we've got Natasha's sculpture, and we've got Maya's sculpture. So Natasha's sculpture, I'm going to set this up the same way here. We've got Natasha's sculpture, which is 5. And again, somebody might sit here and draw one box here that just shows 3/16 within it, but I'm going to draw those separately as 1, 2, 3/16. And we know that Maya's sculpture here is 4 times as tall. So I'm going to skip ahead. Before I drew it out, I had my 2 5/8, so I drew 2 5/8, and it was twice as far, so it's 2 5/8 and another 2 5/8. And then I kind of rearrange them to put the 2 holes together, the 2 sets of 5/8 together. I'm going to jump ahead and go straight to that. I know that really what I'm looking at here is 4 times 5 and 4 times 3/6. I can even break that up. I can say 4 times my 5 whole plus 4 times 3/6, my fractional part. So I'm going to put my 4 times 5 together right now. 5, another 5, yet another 5. We all know this is 20, of course. And another 5. And now let's look at my fractional part. 4 groups of 3/6. That's going to be a total of 12. I'm sorry. I don't know why I wrote 6 before. That's 16ths. 4 times 3/16. Well, that's going to be 12/16. Let me just quickly draw those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If that was too fast, if that was too much going on, you certainly could draw that out and realize that that's 3/16, another 3/16, another 3/16, and finally my 4th set of 3/16. 3/16 plus 3/16 plus 3/16 equals, what I'll show for this entire amount is 12/16. So if I'm looking at what this entire area represents, I've got 5, 10, 15, 20, and 12/16. So I'm just going to, normally I'd put it off to the side here. I'm out of room, so I'll just put it over here. I'm looking at 20 and 12/16. So a lot of people might think that I'm done. After all, 5 and 3/16 times 4 is 20 and 12/16. But that's not my answer, because we have to come back to the original question. How much shorter was Natasha's sculpture than Maya's? So let's look at that. whenever we draw a bar model, I like to look at the differences. I like to be able to figure out, okay, what are we really focusing on? So if this is how tall Maya's was, I'm looking for the difference between Maya's and Natasha's. I'm looking for that difference right there. And there are a number of ways in which I could do it. One option might be to say, okay, if we're trying to find the difference, I know that Maya's is 20 and 12 sixteenths inches, and Maya's is 20 and 12 sixteenths inches, and Natasha's is 5 and 3 sixteenths. And this is one of those great opportunities where we don't have to do any regrouping. 20 minus 5 equals 15, and 12 minus 3 equals 9. 15 and 9 sixteenths should be our difference. Now, another way we could do this, let's imagine for a second, and this is, by the way, one of those problems where you can get away with just drawing out the fractional part. Let's say for a second that I really did draw this and just labeled this as 3 sixteenths. I could have made Maya's the way that I did before and say, here's my 5 and my 3 sixteenths, another 5, and 3 sixteenths, another 5. I'm going to try not to run into my own writing. I don't think I'll be successful though. And 3 sixteenths. And lastly, oops, I'm writing over my own work here. 5 and 3 sixteenths. And really the difference is these are both showing, not perfect here, these are both showing the same amount. Again, here's that difference. So what I could look at is to say, all right, in the difference between Natasha's and Maya's, I've got 5 holes. Well, 5 times 3 is 15. And we've got 3 sixteenths, 3 sixteenths, and 3 sixteenths. Well, that's 3, 6, 9 sixteenths, 15, and 9 sixteenths. And you'll notice that we're getting the same answer using 2 different ways of solving it. 15 and 9 sixteenths. I know this looks really messy right now, and it does. And that's because on one diagram, I did 2 different strategies. Before I started adding in this part in the blue, it was a clear way of drawing it out and using subtraction. But if you're someone who really likes to see it visually, draw them side by side so you can compare. Here's Natasha's. Maya's is 4 times as long. If we're looking at the difference, that's this remaining part right here. Let's take a look at one more problem for this video. This is the third one here. A seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. How many yards of fabric does she need for now both dresses? So I'm just going to highlight some of my key information here. 1 5/8 yards for a child's dress. 3 times as much for a women's dress. We're looking at how much does she need for both dresses. So I'm going to set this up same way for my bar models. We're going to do a child and a woman's dress. So if the seamstress needs 1 5/8 yards, let's set this up. Here's 1. And again, I like to do it 5/8. 1, 2, 3, 4, 5. And I'm going to label that. That's 5/8. So to make a woman's dress, we're looking at 3 times as much. So that's 1. And for this one, I'm going to slow down a little bit. I'm going to draw it 1, 2, 3, 4, 5. Another 1. And another 1, 2, 3, 4, 5. another 1, and another 1, 2, 3, 4, 5. All right, so I've visualized it right here. Now what we're looking at is what's the amount in all? What's our total amount? So I could just redraw this and put 1, 1, and 1, and then put my 5/8, 5/8, and 5/8 all together after. But let's look at other ways in which we could do this. I could sit here and I could add it up. I'm looking for the total for both dresses. So I could just come through here and say 1, 2, 3, 4. So that's 4 whole. And then 5/8, 5/8, 5/8, and 5/8. That's going to be, gee, that sounds like 20/8. So I've got 4 and 20/8 for this one. 5, 10, 15, 20. And so I can sit here and I can say, well, I know that I can pull out 2 wholes. That's going to be the same as 16/8. And I'm left with 4/8 here. So let's put that together. I've got 4 whole. I've got then of my 20/8, 2 and 4/8. That sounds like I'm going to end up with 6 and 4/8, also known as, if I'm simplifying this, 6.5 yards of fabric. So that's one way I could solve it. But again, like we talked about before, I could also draw my pieces together and show there's my 1 whole. This is redrawing this bar. 1 whole, 2 whole, and 3 whole. And then I can take 5, 10, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're getting there. 12, 13, 14, 15. And I know that 8 of them, because we're working in eighths, that 8 of them, 1, 2, 3, 4, 5, 6, 7, 8. 8 of them is going to make another whole, and that leaves me with right over here 7/8. So let's look at how we can solve this now. Now I can write this as I've got 1, 2, 3, 4, and another whole makes 5. 5 plus, here I have 7/8 plus another 5/8. Well, really what I can do is I can do a little shifting here. I can take one of my 5/8 and send it over that way. So I can make this instead 5 plus 8/8 plus 4/8. I just took 1 minus 1 here, plus 1 there, and now I've got another whole. Now it's 6 and 4/8. And again, we've got 6.5 yards. So again, these are two totally different strategies, but both of them were able to get us the same answer. These are just 3 different examples of how a bar model can help you to visualize a solution to a fractional word problem. I'm going to put up a few more videos to walk you through some of the different strategies, and I hope this was a helpful guide for you. Have a great day.